Okay, good morning. And first foremost, I want to say to thank you for your taking time to join our webinar today to learn how to run Gage R&R and bias using the Minitab Statistical software. So I'm Nosalawati. I'm the technical support specialist at Bizit Systems. Bizit Systems are independent local representation for Singapore, Malaysia, and Batam, Indonesia. Okay, so if you are the first timer join our webinar, this webinar not so comprehensive since we run for only 1 hour. So to gain more for every topic based on your interest, we recommend to join our training. So it will be more comprehensive rather than this webinar, but maybe you can give some idea how to run it, this Gage R&R and bias. Okay, so a few housekeeping notes before we begin. We have a Q&A session after the presentation. So please submit any question you have and we will try to our best to answer them if have time. If no, I will answer afterwards by email. And then we recommend you review this webinar on your laptop or PC for the best result. So please fill out our survey before you exit the tab. This survey will help us to improve the quality of our upcoming webinar. Maybe you want to have a new conductor for webinar, something that one, okay? And then we record this webinar and upload to our website, www.bizit.com, and our YouTube channel, Minitab Malaysia and Singapore. So there's no problem if you miss anything or want review afterwards. So now Minitab already more than 50 years in the market. So Minitab not only have a Minitab statistical software, but we have a 5 others product as well. We have the Minitab Connect. It's a for data transformation and dashboard. So if you're looking for a dashboard, so you need to go for the Minitab Connect. And then we have the software predictive modeler. Now we have some algorithm inside the SPN available in Minitab statistical software, but it will be on the module like predictive analytic module. And then we have the online trainer. It's an online training, consists of few models like statistical inference, regression, statistical quality control, design of experiment, and so on. And then we have also some projects and ideation. We have Minitab Engage. Okay, and then we have a Minitab workspace. So workspace is something like you coming from the link, like you want to see or want to create the FMEA, VSM, something that one. We have a lot type of a template already in the workspace. So if let's say you look on that, so you can go for the workspace. So Minitab Engage is something like you want to monitor your project, and then you want to see in the Engage also have the dashboard, something like Minitab Connect, but just on for the purpose for monitoring the project. So let's say you have your management want to see the status of your project from every department. So you will use you will suggested to use the Minitab Engage. Okay, but today we focus on our flagship product, Minitab Statistical software. So if you interest further to know others product, please let we know so we can provide demo on that. So for those who are new, Minitab Statistical software is a software package for statistical analysis. So include variety of statistical tools currently available in Minitab. So we consider it will be powerful statistical software since everyone can use, whether you are statistician or non-statistician. And then I think most of our customer is from not the a pure statistician, but more from the engineering, manufacturing, executive, manager, and so on. So we can consider that one is a professional use, but not have a more in deep either statistician. Okay, and then now, okay, I'm not sure is it you already know, but aware not for this. Now Minitab available for the web apps. Okay, for existing customer, hopefully you already tried it, this web app. So maybe have tried it. Feel free to share your experience with us. So we want to hear more on this. Is it okay or not? Is it easy to accessible for this one, or something like you want to do the continue analysis where you go, you can do the analysis. Okay, for those not yet try, no worries. After this webinar, you can try it. But just one highlight here, the functionality is almost the same as per desktop, but have a few features maybe not similar as per desktop as. So I will try open the Minitab. Maybe I will try open the web apps to show you. Okay, how to dedicate this one. Okay, so you need go to Minitab portal and then log in your email. Okay, so I think email same with your subscription, something that one. Okay, so for this case, my email. Okay. Okay. So once you log into Minitab portal, you will see the My Product. So under My Product, you can see the Minitab Statistical software. So you click on that, and then you will see the Open Web App. So since I have a 2 subscription, okay, and then I just choose for this one is a Open Web Apps. Okay, so you open the web app, so it will be automatically to this Minitab Web App. So you see, it will be the same. We have a navigator, we have the menu bar here, and then we have the worksheet here. So for this one, I love it, this web app, since because if let's say you are the first timer use the Minitab, so you're not able to remember where is the Gage R&R in the menu button. Okay, so you need to go for the stat, you need to go for the quality tools, okay, and then you need to find the Gage study, and then after that you need to go for the maybe the cross, or maybe you go for the type 1 Gage. So something like you will take some time. But in this web app, you just go for the search button, and then you type the Gage, okay. Okay, so maybe this one. So already appear in this, just you click and then directly to do your dialog box. So it something like, not the automate, but it's something like reduce your time. Okay, I think if let's say the first timer is a good to see, because if let's say you need to remember all the thing, where is the Z, where is the say, so it will give take some time to do. Okay, so the dialog box here is the same. Okay, so for example here, go back to this one, it will be the same. So no worries for the old user. So it's a part number, operator number, it's the measurable data will be the same. Okay. And then the other thing, maybe you can share. Okay, after you run it, and then you will share with your colleagues or something that one the output. So no need to copy and paste it to others application, and then you need to send it. No need. So you just share it that one after you run, and then you can share. You have the share button here, so you just share it. So maybe this one is one of the best part if you want to using the web apps version. Okay, so I think we continue again for this. Cool. So this one is example. This one is the example of the tools available in Minitab. Okay, so this is for the quality side. Okay, so we have MSA. So today we focus on the Gage study, and then we have control chart. Maybe others next month or others month. Okay, we have a capability analysis. We have a acceptance sampling, and then we have tolerance interval. For the liability engineering, also we have in the Minitab Statistical software. We have the product development, we have a design of experiment, we have the power and sample size. Okay, and then we have, I think most of us nowadays, nightmare with the machine learning, predictive analytics. So Minitab also have that kind of the algorithm. So we just added with this cut classification and regression tree, and then the traditional something like regression we already have in the Minitab Statistical software. Okay, and then here is we have the process validation. If let's say you are coming to validate something that one, so this one is the stages, and then all the tools are available in Minitab Statistical software. Okay, so since Minitab is we consider complete tools for analysis because we not offer the by the package, we have the whole one. Okay, so our customer coming from the various of sector include the manufacturing itself, the academician services, and so on. So you can see the list of our customer, this one. Okay. So maybe you are part of this company, okay? But if let's say you're not part in this company, also can, okay? Don't worry about that, okay? So agenda today, we try to explore what is the Gage R and R itself, what is the R, the first R, second R, and then we go for the bias and linearity, and then how to run using the Minitab Statistical software. So I go to the overview. Okay, we go for the overall picture before we go for the Gage R and R. So we start with the measurement system analysis. It's a collection of method you can use to assess your ability to collect the truthful and reliable data. So measurement system analysis is critical component for any quality improvement process. I think we have 5 FMEA. Okay, one of that is a MSA. So evaluate your measurement system before using control chart, okay, capability analysis and others analysis like DOE, predictive, to prove that your measurement is accurate and precise and that your data are more reliable. So before you go for the control chart, before you go for the capability analysis, so you must do the measurement system analysis, okay, because you want to see is it accurate or precise on that. Okay, that one is something like this, the first step to validate your data set. Okay, before you measure like stability and capability. Okay, so measurement system and it can include all the things like measurement device, or we call it gauge, and then we have the measurement procedure, and then we have the operator that affected the measure of a part itself. So MSA help determine how much of the overall variation found in your data due to variation or error measurement system itself. So error in here, we classify into two. It's accuracy and precision. So the accuracy is described something like different between the measurement and the part of actual value or your target, something like one. So we consider that is accurate. Something like your measurement must be 8 cm. Okay, so maybe you do the measurement and then you get it 7.9. So it will be differences between your target. So not accurate one. And then the precision is described the variation you see when you measure the same part repeatedly with the same device. Okay, so I think the easy way to visualize the accuracy and precision is to think your target here. Okay, is to think the target here, and then the blue eyes in the actual value, okay, that you are measuring, and then a good measurement hits the target here in the center each time. Okay, so doing the MSA is looking at the pattern of a shot. Okay, so you can see if it where is a device is having problem and how to adjust it if needed. So we want this one accurate and precise. Maybe during the experimental, your device, your gauge, your operator, something to like this one, precise but not accurate. And then this one is accurate but not precise. This one is neither is accurate or precise for this case. Okay, so we want this accurate and precise. So in order to measure this accurate and precise, we have some tools are available in Minitab Statistical software. The first, maybe you already know, is a Gage R&R, is a repeatability and disputability. But in the Gage R&R in Minitab, we offer for 3 types. It's a cross, nested, and expanded. So I will explain after this what is the cross, what is the nested, and what is the expanded. And then we have the Gage run. The Gage run is to identify the source of variation. You plot the plotting for this one. And then we also have the Gage linearity and the bias study. So this one is we show after this, okay, after go for the Gage R&R, we show the linearity and bias. So that one is we use the Gage linearity and bias, okay, to evaluate the accuracy of measurement system, and use when you have reference value for each representative the part. So you have a part and then you have the reference value for the part. So you're able to use or using the linearity and the bias study. And then we also have the type 1 Gage study. So for type 1 Gage study is the something like preliminary evaluation for your bias and repeatability. So we use this one when one operator measure one part for multiple time. Okay, so for this side is a measurement data set. You measure your diameter, your strength, so whatever is the length, so your weight. So all this is for continuous variable. But you want to see or you want to do the MSA, but your measurement is something like accept, reject, go, no go. Okay, so something is attribute. We use the attribute agreement analysis. For this case, maybe we look on the consistency and accuracy. Okay, so you have between your appraiser, okay, between your with your standard. So we look on the attribute agreement analysis. So we have two continuous variables or attribute variables. So mean to say that if let's say your measurement is not numeric, by the text number, okay, the text, it will be use MSA also, but different tools, we call it the attribute agreement analysis. Okay, so if we can see on this Minitab, so I will open the Minitab. Okay, so you can see all that MSA tools are available in Stat menu. Stat, we go for the quality tools, okay, and then you go for the Gage. So it's one type 1 all this, and then we have the attribute agreement analysis. Okay, for this. So how to get it? Go for the stat, okay, go for the quality tools, and then for Gage, you choose the case, and then that one is here. Okay, so I will back to the PowerPoint. Okay. Okay, so now we want to measure the precision and then accuracy. So in order to measure the precision accuracy, one of the tools is, we call it the Gage repeatability and reproducibility, or we call it is a Gage R&R. So Gage R&R is a critical step in any statistical involving for continuous data. It's a measurement data, decimal point. Okay, your numeric with the decimal point is something continuous data. So Gage R&R used to define the amounts of variation in the measurement data due to the measurement system itself. So for the repeatability is referred to the variation observed when the same operator, okay, measure the same part repeatability with the same device. Okay, and then for the reproducibility is the variation observed when different, okay, different operator measure the same part using the same device. So maybe O here is refer for operator to differentiate between repeatability and reproducibility. Okay, so O here is a operator, so different operator. So maybe we go for the operator 1, operator 2, and operator 3. But for this one, is all the same for this case. Okay. Okay, so in visualize, okay, so you have your part. Okay, you have your part. You want to measure 10 part, okay, and then you assign for 3 operator. Okay, so this one is between the part, we call it the part to part variation. Okay, part to part variation. So we need to say that this one divisibility across the different part. We already have the variation here. Okay, between the part itself, and then every operator here measure all the 10 part here. They measure for 3 times. Okay, so they repeat for the 3 times for each other, and then total run for this will be 90. Okay, and then from each operator here, okay, because we have 3 operator, so we call it, this one is a reproducibility. So the variability when the same part is measured by different operator. Okay, so 10 times 3 and times 3 here, so we get the 90 runs. Or you can go for the in the Minitab, we can create the we call it the worksheet for this, how to run it. Okay, for this one, we want to see how many operator 1, standard 1. Okay, so we have that kind of the features to create the worksheet before you run the analysis. Maybe using the Minitab will help you in term randomization. Okay, so you can randomize your worksheet here. Okay, so for the reproducibility, it actually is a measure for the 2 part. Is operator itself, operator by the part. So you can get the part to part variation. You can get the repeatability and reproducibility. So the total Gage R&R is total is a sum of the repeatability and reproducibility. And then with the part to part, we get the total variation. Okay, and then for the Gage, it will help you. Okay, some like your question something like, is my measurement system capable of discriminating between the part? So you look on the NDC here. Okay, is it the variability in my measurement small compared with the manufacturing process variability? So how much variability in my system is caused by different operator? Okay, so if let's say you have this kind of the question, maybe Gage R&R will help you on this part. Okay, and then the type analysis of a gauge, we have a 3. Just now I mentioned we have a cross, we have a nested, we have expanded. But today I just focus on the cross example. Okay, so the cross is here is we use when, okay, when you have a same operator measure the same part, and then we use the cross. But if let's say you have the operator have cannot measure for same part, okay, every operator not measure in the same part, so you need go for the nested. And then if let's say you have another consider another factor beside the part and operator, so maybe if a location for your measurement or something like temperature during the measurement, so you have consider others factor, so you will go to the expanded Gage R&R study. Okay, so we have 3 type of this one, so you need very clear part what type of your situation now. Okay, so is it will be used to cross or nested or expanded? So no worries, no need to remember all that thing. So you can go for the Minitab, go for the stat, go for the quality tools, go for the gauge. Okay, if let's say you scroll and then you choose select this one, so you can see the assess the variation. That will be okay, something that one. Okay, so they will mention that Okay, every operator measure every part in the study. Okay, so in Minitab, so nested, what is for nested? So this one is every operator cannot measure all the parts. And then for the expanded, is this additional to part and operator such as temperature and location. So they will give you the sum ticks before you choose it. Which one? Is it across or nested or expanded for here? Okay. Okay, so for this case, so hopefully you will get this stat. Okay, so go for the quality tools, go for the gauge, and then this one. So we try with create a worksheet. Okay, so you can go for the stat, quality tools. Okay, and then you create a gauge study, and then you just go for the create R and that study worksheet. I think one is important because if let's say you do manually, so maybe randomization is not able to show it. But for this case, you go for this one, and then maybe the default one, okay, by default by Minitab is a 10 part. Okay, if let's say you have a part name, so you can go here, and then if let's say your operator, how many operator, but here we try with the 3 operator, and then number of replicate, we have a 2. But if let's say you go for the randomization, you go for the option. Okay, so we suggest you have a randomization for this gauge study because you want to study about the variation. Okay, so for this case, randomization run with the operator default by Minitab. So if let's say you don't want, so you can go for the randomize or the run, or maybe you can go with the best this one. But I just go proceed with the default. They click OK, and then after that click OK. So we will see that. Okay, this one is a worksheet, not yet the experimental. Okay, so after this, you do the experimental. Maybe here is a measurement. Okay, so you will see that this one is a run order, your part number, and then your operator. So how many? 2 times operator repeat for this, and the operator measure all this one. So you will measure and then put here. After that, you want to run it, so go back to the stat, go back to quality tools, and then go back to the gauge study, maybe the cross. Okay, something like one. So this worksheet also you can import to Excel. Okay, so but if from the Excel into this one, in this like this standard one, okay, because Minitab is a column based, so one variables, one column. Okay, it's not the cell based. So if let's say here, okay, so you just import your Excel file into this worksheet. Okay, so no worries, go for the file, go to open. Okay, and then you find where is your Excel file, and then you choose Excel file, and then you click open. So will be appear in here. Okay, so you are no need to worry if let's say you already run the Gage and art. Okay, no need to copy and paste it, type it. You just can import into this worksheet to get do the analysis part for the Gage and art. Okay, so I go back to this one. Okay, so we try with this case study. Okay, so I think this one is the manufacturing of the fuel injection nozzle installed the new digital measurement system. So investigator wants to determine how well the new system measure the nozzle. They could the 9th nozzle. So now 9 nozzle is a nozzle here is a part. Okay, to identify the measurement, taking each nozzle, each operator repeat for process twice. Okay, so every operator repeat for twice. Okay, and then for total, it will be 63. Okay, 36 measurement. So the specification of the nozzle diameter, it will be this one. Okay, 9012 plus minus 4. The tolerance will be 8 microns. So this one is something like optional. Okay, I will show this one. Let's say you doesn't have a tolerance. Okay, if let's say you put the tolerance, what happened to your analysis? Okay, you will get some more information, something that one. If you put more into the dialog box, maybe it will get you will get more information. Okay, but you must be clear part how to interpret the result. Okay, once you add more, and then you will get more, and then after that you need to interpret. Okay, to show to your management or something that one. Okay, so I open that data set. Okay, so this one is a one data set. Okay, okay. So this one we have the nozzle here. Okay, nozzle is considered a part. Okay, so we have a 9 part. Okay, and then we have a 2 operator. Okay, so every operator repeat for 2 times. So the total run here is a 36. Okay, and then this one is the run order, and then this one is our measurement or diameter here. Okay, so so every operator measure every part. Okay, so we'll go for cross. Okay, so go for this one. Sorry, step for the stat, quality tools, go for the gauge study, you choose cross. Okay, for this case, a part is a nozzle. Okay, your operator is an operator. So your measurement data will be diameter. Okay, so for this case, maybe you have option 1. Okay, just now you have your spec, your lower spec, your upper spec, and then if let's say you have, so you just put in here. Okay, so for this case, okay, so it's our tolerance 8. Okay, and then we click this one. Okay, so this one is your optional. Okay, so if let's say you have your historical data before this, you can use this one. Okay, they click OK, and then I go for OK. Okay, maybe I go for the graph. Okay, option here. So draw a graph on separately, okay, or one graph or per page. So I just propose it with the default first. Click OK, and then click OK. Method of the analysis, we go for the ANOVA or XBAR. So if let's say you don't want ANOVA, so you can go for the XBAR. Okay, but I think it's just suggested to you to use the ANOVA. Is more information we will get rather than XBAR. Okay, click OK. Okay, so now you will get the output. So I will go to stat, go to quality tools, okay, go for the gauge study, and then you choose the cross. Why cross? Every operator measure every part. Okay, click cross. So for the part is our nozzle. This one is operator. This one is a diameter. And then you choose the operator. And if let's say you have a more information, you go for the option. So put here is a process tolerance. Then you click OK. And then you click OK, you will get the result, this one. So, okay, another thing, if for the gauge, run the gauge RNR, it will give you more input. Okay, which one is you must use. Okay, we have a ANOVA, we have a Gage RNR study here, and then we also provide the visualize for this case. The same thing, but just different visualization. Okay, so for this case, we try with this ANOVA first, since we want to see is a significant or not for the part with the operator. It's a nozzle with the operator. Is have this kind of the significant or not for this case. You look on the p-value here. So for the operator, it's significant. This one is not significant. So that's why this one is not significant, since this one is a bigger. P-value is a bigger rather than our alpha. Normally we use 0.05. Okay, so that one, Minitab create another ANOVA table. So now without interaction between part and operator. So we get the new ANOVA here. Okay, so based on this one, is a operator is a significant. Okay, and then we go for the Gage RNR. So in order to explain this value, is it okay? Is it acceptable or not acceptable? So we get to this part. Okay, go to back to this part. That one I try with to just show it based on the AIAG standard. So I think most of practitioner using this standard to evaluate the measurement system. Okay, based on this one, maybe your company have other standard. Okay, so maybe you can share with us after this. Okay, so for this case, we have a contribution, percentage contribution. So if let's say your percentage contribution is a 1 or less, so we consider this acceptable. So measurement system itself will be acceptable. But if let's say your percentage contribution, it will 1 to 9, okay, you will give potentially acceptable. And then if let's say 9 or greater, is not acceptable. Or you don't want to use the percentage contribution. Maybe you want to use another matrices like percentage tolerance, your standard variation, and then your process. So the measurement is under 10% is acceptable. 10 to 30% is potentially acceptable, and then over 30% it will be not acceptable. And then we look another measurement is we call it NDC. Okay. NDC will be suggested by AIG is you need to have 5 or more. Okay, so actually for the NDC, NDC here is referred to a number of group your measurement tool can distribute from the data itself. So you can how many category, how many level in your measurement data, you can group them. So higher number is good for this case. So but highly recommend from the AIG, if let's say your NDC is a 5 or more, it will acceptable. Okay, so by maybe you look others standard or others practitioner use the NDC first, look at the NDC first, and then after that look on the contribution and the tolerance to assess is it the measurement system is acceptable or not. Okay, doesn't have any must be use the NDC first and then contribution. It will depends on you. Okay, your preference which one, but for here we need to use all this one. Okay, we need to look on this one. Okay, look all this statistic measurement. Okay, so for this case we'll back to the Minitab. Okay, the output here. So here is a contribution. Okay, so for the percentage contribution, actually it will benefit for you since they will add that all this will be 100. So easy to explain it. Okay, but for the standard variation here, okay, standard variation here is not added 100. Okay, we something like percentage, you can get the standard deviation, and then we'll get this tolerance. Okay, and then standard deviation and the standard tolerance. So you might look on this. For this case, we go for the total R here is a sum of from the repeatability and reproducibility. But for this case, the total R here is 0.8, is a less than 1. Okay, and then the part to part is more than this value. Okay, so we consider this measurement system is acceptable based on the AIG standard. And then if let's say you want to go more, okay, this total is 0.8 10, but it's coming from what? Okay, from repeatability or reproducibility. So for this case, its highest value is coming from the repeatability. If let's say you want to go more on this part. Okay, so we compare the total gauge with the part to part. Okay, which one is the lowest, gauge lowest rather than part to part. So it's acceptable. But after compare with this one, and then you look on this value, compare with the AIAG standard. So in order to improve which part, is it repeatability or reproducibility? So you look more on this repeatability or reproducibility. Okay. So how they interpret for this case. Okay. So we And then after that, maybe the one used on the numbering, maybe you can go visualize this one. So easy to see, but to part is a highest rather than total gauge here. So it will acceptable. Okay, so for this case, we have this kind of the graphical, and then we have the R here is consistency because not outside from the control limit here. Okay, so for this, and then we have the nozzle diameter by the nozzle, and then we have the operator itself. So you can see that the box plot here, okay, seems like same. Okay, not the highest differentiate between operator 1 and operator 2. And then for the operator is interaction. So already know this one is not significant. Okay, so that's why it will be the same here. Okay, so the same, maybe the same information, but this different reporting. Okay, maybe you go for this one, but if let's say you want get one graph per one page, okay, you go back to this, and then you go for the option, and then you choose to draw graph on the separate graph. Okay, then you click OK. After that, you click OK. So Minitab will appear one graph for this. Okay, so it will be different for this. Okay, in one pages you have 6 picture, but this one is one picture, one graph available. Maybe you just have one to this. Okay, so after you got, maybe you want to send the word, so send the PowerPoint to do the reporting purpose for this case. Okay, and then other information is something like just now I put the tolerance. Okay, I put the tolerance. If let's say you doesn't put the tolerance, so you might get, once I put the tolerance, you will see that you can get the standard tolerance here. But if let's say I not put the tolerance here, so we go back to this, okay, option. Okay. Maybe I just put the lower spec. Okay, for this case, it's a lower spec. Upper spec. Okay, 9016. Okay, so click OK, and then, sorry. Click OK, click OK. So you see that without this one, okay, you can run it, then you click OK. Okay, without the tolerance, so without the tolerance value, a spec limit, so you cannot able to have the percentage tolerance. So that's why I mentioned just now, if let's say you have more information, you put in this option, okay, and then you will get more information on this output. Okay, so it will appear based on this one. And then maybe you have your historical standard deviation, so you can put here, maybe here, and then you can use a part in the study as to estimate the process variation here. So more further for this case. Okay, we click OK, and then you click OK. So you will see that this one, it will be changed. Okay. Okay. I think that's all for this case. We continue back to this already put here. So this one, to rectify the sources of variation is coming from the pipe, coming from the operator, or coming from the interaction between nozzle and the operator is a part by the operator. So that's why this now is not significant. So we remove this, we come out with the new ANOVA without the interaction. Okay, so further this one, we look on the percentage contribution. Maybe we look on the NDC. So NDC here is more than 5. So it will be good. And then from here, you compare this total out with the part-to-part variation. Okay, it's a less than. And then this value, you can compare with the AIG standard. Is it acceptable or not acceptable? Okay, so for this case, it's coming from the repeatability. So you need to go further how to tackle for the repeatability. And then here is a graphical here. Okay, so that's why for the Gage R&R is look on the precision. But if let's say we look on the something accuracy and the linearity, so here today we show for the how to run the Gage linearity and the bias. Okay, but for this case, just want to see or look on the is a measuring for accuracy part. Okay, so if let's say look on the, you want to see on the precision, okay, your variation precision, so you look must go for the Gage R&R. But basically, we use this Gage linearity after you run your Gage R&R. Okay, so linearity is show how accurate your measurement are through the expected range of measurement. So another term is here is a bias, how well your measurement compared to a reference value. So if let's say you doesn't have any reference value, so you're not able to run the bias. Okay, so the Gage linearity and the bias answer two questions. Okay, something like, does the Gage have consistent bias throughout the operating range, or should the Gage be calculated for so that it can record and bias measurement? So if let's say you have both this kind of the question, so you will try with the Gage linearity and the bias. Okay, we try with this example. So this example is an engineer want to assess the linearity and bias of a measurement gauge that is used to measure inner diameter of the bearing. Okay, so the engineer choose 5 parts that represent the expected range of the measurement. So each part was measured by layout inspection to determine its master measurement. And then the one operator randomly measure each part for 12 times. So the engineer performed a cross gauge study previously, and then using the ANOVA method to determine the total study variation is this value. So after they run the gauge R&R, they do the gauge linearity and bias. So from result from the gauge R&R, they will come out with the total study variation. Okay, so that's why we suggest you run the Gage and R, and then after that you further with the with the linearity and the bias study. Okay, so I think easy for you to understand this this experimental. Maybe you can go for this one. Okay, so we have the 5 part. Okay, and then every part have the standard. Okay, the reference value. And then here is the response. So because just only use one operator for this case, that's when we doesn't have operator for this case. Okay, so how to get it, this linearity and bias? So go for the stat, go for the quality tools, go for the case study, choose the linearity and bias study. Okay, linearity and bias study. Click here. Sorry. So our part is a part. Okay, reference line is our standard. Okay, your master maybe put here is a master. Maybe you put the standard, and then the measurement is our response. Okay, and then for this case we already have. Okay, for the process variation. Okay, is here is a 60.53. Okay, and then you click OK. So we'll see that we have the Gage linearity and bias report. Okay, but for this, I will redo. Okay, how we do? Stat, go for the stat, quality tools, Gage study, and then you go for the linearity and bias study. Okay, so for this one is a part, our part, reference line is our master or standard, and then this one is the our measurement, and then this process variation is maybe you already have your from the Gage study, and then you click OK, so you will get the this linearity and bias report. Okay, so for this you will have a reference line. So this one is they using the regression. Okay, so that one is this one is the confidence interval, and then this blue dot is our data, and then the red is average our bias here. Okay, so we look on this one. Okay, how to interpret this. Okay, how to interpret this. You can see that we have a two table here in this graph, the gauge linearity, and then here is a gauge bias. So we look on the linearity first. So based on the slope here is the P, okay, based on this one, what is the value for the linearity? So you can go for this case, okay, you get this percentage linearity, and then you will see this value is a 30%, okay. So we should indicate the gauge linearity explain 30% of the overall process variation, okay. And then the slope here, okay, slope here is your p value is a less than 0.05, okay, which indicate the slope is significant. The linearity is present in this measurement. So to verify that you can go for this linearity or bias, it will the highest one. It will be the linearity. So to statistical evidence, you go back to this p value here. So for this case, they have a linearity in the measurement system. Okay. So because have a linearity is significant, okay, linearity is significant, the engineer must use the individual bias, and not the overall bias. Okay, the individual bias here. So this one is we have a 5 part just now. We have two, maybe I'm not sure. This one is the 2 cm, okay, 4 cm, okay, 6, 8 and 10. Okay, and then you look on this per P. The significant here is a 2, okay, is the 8 and the 10. Okay, the individual bias vary from the 0.2. Okay, so this one is the 0.2 to 3.7% bias in this measurement. Okay, so you can see this is the lowest number percentage of bias, and this was the highest. Okay, the range. Okay, and then the reference value have the bias is significant is the 2, 8 and 10. And then the value for the 4, okay, because this highest, okay, rather than 0.05, so it's not significant. So bias is not in this part. Okay, bias we just only have this in this part. Okay, part 2, part 4, part 10. Okay, so that one is a linearity. This one is for the bias. Okay, so you can see in this graphical for the linearity is higher rather than bias. So it's a significant. So for this case, okay, they have a linearity on this one. Okay. So we go back to this. Okay, go back to this. Okay, the explanation here. So how to, we have a two table here, okay, in one graph. Okay, that one is the negative, okay, so positive. So that one is a regression line. Okay, so regression line, we use the least square method to get it this value. Okay, your R squared. Okay, so we try with the assistant menu. Okay, but for information, assistant menu is not available in the web apps. Okay, sorry to say. Okay, for this case, the other differentiation between desktop app and web apps, in web apps doesn't have assistant menu. Okay, so if for those love with the assistant menu, so we highly recommend to use the desktop app. Okay, so go for this assistant. Okay, you go for the measurement system analysis. So maybe it will be confusing. That's why I start with the webinar with the measurement system. It will be overall. But we put of this Gage. Okay, you go for the quality tools, you go for the Gage study, and then you go for this one. For assistant, we not directly for the Gage. Okay, you go for the measurement system analysis because we have a tool here. Is the Gage, and then we have the attribute. Okay, so for this case, we go for the cross. Okay, and okay, sorry, I need to open this data set. Okay, so go for the assistant, go for the measurement system. Okay, so cross Okay, so for this case, is our operator, your parts is nozzle, your measurement is diameter. Okay, so maybe estimate here. Our tolerance just now is 8. And then you click OK. Okay. Okay, so we do assistant measurement system analysis. You go for the cross, and then you operator, your nozzle, your diameter, and then your lower spec, and then you click OK. So you will see this. Output. Okay, it always same information, different presentation. Okay, so for this case, we have this kind of the graph. Okay, and then we have the study information. We have the comment here. Okay, so they put the general rules. It will based on the AIG standard, and then they have a variability of sources here. Okay, and then they come up with the variation report here. Okay, so we look on this part, and then we have a main effect box plot as per the stat menu also, and then we have the tolerance or gauge table, gauge RN table. For this case, we have the part value for the standard deviation, study variation, sorry. This one is the percentage of tolerance, and then they come out with the report card. Report card here is the amount of the data, maybe it's not so good lah. Okay, for this case. This one, okay, I will compare it. Okay, so this one is from the stat menu. Okay, you will see this, and then this one is from the assistant. Okay, so the input it will be same, but just different graph presentation for here. See, and then I noticed that in the assistant, you're not able to see the percentage contribution. Okay, you will see the standard, the study variation only. If let's say you look on the percentage contribution, so you will go for the stat menu. Okay. Okay, so for information, starting with Minitab 21.3. Okay, Minitab trial will be more easy, accessible for the gauge, for the measurement system itself. They provide you some like module. So you go for that module, and then you can see the gauge, RNR, you can see the bias study in one stop center. Okay, you go, for example, okay, for example, you go for the solution models, okay, and then you go for the capability, okay, and then you can see that there's measurement system analysis. I'm not able to access on that yet. Okay, so we see this in this one. Okay, you click on this, and then you will see this KPI. Okay, so in one stop center. So no need go for the stat, no need go for the quality tools, no need go for the case study. So you will see in this one stop. But this one is an additional subscription for this case. Okay, too easy for you to run the measurement system analysis. Okay. And then this one, please type question into the question box. Okay, if let's say you have question. Okay. Okay. Okay, we have question here is functionality in term differences between web apps and desktop app. I think the first I show, and then the second one I show it in the desktop, in the web apps not able to run the assistant. Okay, and then the others, the sequence of the okay, sorry, I go back to the web app. Okay, I go back, open the web app. So I think another way is for the graphical. So you can see that in the scatter plot is something that one. Okay, you will see the colorful the one. Okay, the others, it will be the same. Okay, you can import. Okay, you can import data from the okay, you can open data. Okay, you can open data from the Google Drive or something, OneDrive. Okay, But in the desktop also, you can open the data. Okay, you can open data from the repository, but you cannot save it into the cloud. Okay, you can open up only for the desktop. But for the web app, okay, you can open data from the Google Drive or OneDrive, and then at the same time, you will save it automatically save. Okay, for that. Okay. And then for the desktop app, you can save your output into your PC, okay, your laptop, but you need to go for the download a copy. Okay, you need download the copy to save in order to save in your local drive. Okay, because it's automatically cloud like Google or OneDrive, but you need to connect with your Google and OneDrive. Before you connect, you have some information you need to fill up, and then after that you will directly import from your Google Drive or OneDrive. And then the best part of that one is, if let's say you save it your data sheet on the Google Sheet, so already you can also import from here for the web app version. Okay. Okay, so hopefully answer your question for this case. Okay. So the rest I will answer on by email. Sorry for that. We already okay, I will answer. Thanks for your question, but I will answer directly by email for you. Okay. So I go back to this one. Okay. So if let's say yes, we share the slide, but you need to give your email into the chatbot, or chatbot is it for me to send it after this. Okay.